Well, what do you say we take another look at sum and difference identities? And this time we're going to use sum and difference identities to verify trig identities. And you may recall when we're verifying trig identities, sometimes we work just on one side of the equation, but there are occasions we may work on both. However, I think in the two examples I'm going to cover here, we're just going to work on one side of the equation. So let's see what we have. All right, well, we've got the sine. We're asked to find and verify that the sine of 90 degrees minus theta, which is an angle measure we don't know, is equal to the cosine of theta. Well, let's see. Well, it looks like I've got a difference identity where the sine of a minus b is equal to the sine of a times the cosine of b minus the cosine of a times the sine of b. Well, let's substitute in our 90 degrees and our theta into our difference identity function. And when we do, then that's going to give me the sine of 90 degrees times the cosine of theta, and I don't know what theta is, minus the cosine of 90 degrees times the sine of theta. Now let's see, the sine of 90 degrees, and 90 degrees is also pi over 2. Well, anyway, let's move on. So when the sine is at 90 degrees, the sine is equal to 1. And so we have then at this point 1 times the cosine of theta. And the cosine at 90 degrees, well, that's 0. And so now we've got 0 times the sine of theta. Well, 0 times the sine of theta, whatever it is just going to be 0. That's going to cancel out. And I'm left with 1 times the cosine of theta, which is just the same as the cosine of theta. And shazam, there we go. We have verified it, that the cosine of theta is equal to the cosine of theta. Now, there's actually another way that we could have done this, another identity that we could have relied upon. But since we were working sum and difference, I went ahead and used the sum and difference. Probably in real life, if I could remember this next identity function, which is a cofunction identity. And it says that the sine of pi over 2 minus theta equals the cosine of theta. And of course, 90 degrees and pi over 2 are equivalent. And I could have just used that cofunction identity just to say that the sine of pi over 2 minus theta is equal to cosine of theta. And therefore, the cosine of theta is equal to the cosine of theta. Two ways we actually could have solved that. Cofunction identity actually would have been a little bit easier, taken a little less time. But hey, the sum and difference, or in this case, the difference identity, actually worked. Let's look at one more. All right, so this time we got the cosine of 90 degrees plus theta, and we're going to verify that it equals the negative sine of theta. So cosine of 90 plus theta, well, that's going to be a sum identity. And there's a sum identity that we could use, that the cosine of a plus b is equal to the cosine of a times the cosine of b minus the sine of a times the sine of b. And let's just plug in our 90 degrees and our values for a and b, and let's see where we end up. Well, let's see, we got the cosine of 90 times the cosine of theta minus the sine of 90 times the sine of theta. Well, let's see, when the cosine at 90 degrees, well, that just equals 0. So I'd have 0 times the cosine of theta, and again, that's just going to cancel out. That's just going to be 0. And then I've got negative minus, well, let's see, when the sine value at 90 degrees is just 1. Don't forget this little negative sitting out here. And then we got the sine of theta. So in fact, we can verify that negative 1 times the sine of theta, or just negative sine of theta, does in fact equal negative sine of theta. Well, we are done.